All right, so looking at this complex fraction, first step is to factor everything. So as I look at the different denominators, they all look pretty straightforward, so I just get started. We've got 14 over 2 times x minus 6, and then plus 18 over x times x minus 6. Looking at the bottom, looks like we've got x minus 6 times x plus 5 that works out for the x squared minus x minus 30, and then difference of two perfect squares, so x plus 6 and x minus 6 for the factors down there. As I continue, what I'm going to do is method 2. So I'm going to look at all of the different denominators, and as I notice on the top I've got a 2, I've got an x minus 6, I've got an x, I've got an x minus 6 again, but at most I have one of those x minus 6s. And then at the bottom, in addition to the x minus 6s, I've got an x plus 5 and an x plus 6. So I need one of each of those factors, a 2, an x minus 6, an x plus 6, and an x plus 5. So I'm going to put all of those factors and multiply both top and bottom of this big fraction by those list of 5 factors in this case. Then when I distribute to all 4 of those fractions, what happens is when those 5 factors hits the first fraction, the 14 over 2 times x minus 6, it's the 2 and the x minus 6 that are going to schwack, leaving the 14 that I had originally in the little numerator. But then what else? What else amongst those 5 factors is there? Well, there's the x plus 5, and the x plus 6. And so I do the same kind of thinking in the next one. I go, okay, so what factors are there that when those 5 factors hit the 18 over x minus 6, this time it's going to be the x and the x minus 6 that schwack out. The 18 is still there, but now the 2, the x plus 5 didn't get schwacked, and the x plus 6 are still around. Looking at the denominator, I see that the x minus 6 and the x plus 5 are going to reduce out, they're going to schwack, leaving the 1, which isn't much, but I've got 1 as a numerator in that little fraction, and then the 2x and the x plus 6. And finally, be careful, on the last one it's minus 2, and then whatever factors are left after I schwack out the x minus 6 and the x plus 6. So what is that? 2x and the x plus 5. What gets interesting here is that, and let me pause here. What's interesting here is that what's left is pretty complex. I see a 14x, x plus 5, x plus 6, and 18 times 2, that's 36, x plus 5, x plus 6, and downstairs there's quite a bit too. So as I look at that, I notice that if that, on the top, if that plus sign in the middle is separating out the left side, 14x, x plus 5, x plus 6, from the right side, 36, x plus 5, x plus 6, then x plus 5 and x plus 6 are common to both of those terms. So that's what I'm going to do. I'm going to factor the x plus 5 and the x plus 6 out, leaving 14x plus 36 plus 18 times 2. I'm going to do that in the bottom as well, and I see 2x is common to both of those terms. The binomials in this case are not common. It's x minus 6 on one and x plus 5 on the other. But the 2x is multiplied times x plus 6 in the first piece, and x plus 5 in the second piece. So I'm going to factor out that 2x. What this does is it almost completes the factoring to look for what I can simplify. So I also notice that there's not just the x plus 5 and the x plus 6, but there's a 2 inside that 14x plus 36. So I'm going to factor that and get 7x plus 18 for that one. And then I've got 2x, and then simplifying by using distributive property downstairs, distributing that negative 2 times x and negative 2 times 5, I've got my x plus 6 minus 2x minus 10. So I keep going, I keep simplifying, and really all that I've got now is those 4 terms on that bottom packet, the 2 schwack, Those four terms on the bottom packet can simplify because x minus 2x, let's let that keep drawing out, sorry about that. So x minus 2x is negative x, and 6 minus 10 is negative 4. So I'm going to factor out the negative and have it be negative x plus 4 on the bottom. And typically I'll put a extra negative on the top rather than on the bottom. So nothing else schwacks. It's kind of a funky one that not much schwacks, but there's my final answer.